One example is shellac. I'm not telling you chemistry, because chemistry will be taught in the classroom, not in a lecture like this. I've just shown a structure just to give an idea. It's an excretion from a lac bug, which is used as a sealant for surface coating, but it was in short supply during the World War. Scarcity makes persons to look for an alternative. How to go? Go to the lab and find out. Is it possible to make a material which behaves like shellac? Generally what we do, if we want to do something, we go through the literature. Whatever work that our predecessors have done, we go through it, read and find out, is there anything that is interesting to our work, and then try to follow, modify and make a new procedure for what we want. Leo Baekeland is a scientist who wanted to find out a substitute for shellac. And he went through the literature and found that the work of earlier scientists called Bayer, there is an industry named after him, had prepared a material using a household disinfectant, phenol, and a preservative, formaldehyde, and he had told his students to carry out a reaction between them in the lab, and the product was a hard mass which could not be taken out of the flask, and they had to break the expensive glassware to take the material out. And Bayer was so angry that he told his students, never try this reaction again, because it was gunking all his glassware. Luckily, he reported this. This is what the reaction is, and this happened. And Leo Baekeland happened to see that. And he found that this material, porous, hard, which cannot be taken out of the flask, this is exactly what he wanted in the material that he wanted to develop as a substitute for shellac. He carried out that reaction and ultimately patented that. And it came to know as Bakelite, which we are still using, an insulation material, and innumerable uses. Natural rubber. If you go to Kerala, you will see rubber plantations. Chemically, a polyisoprene, a small molecule called isoprene, you polymerize it. If you pierce the trunk of the tree, a white liquid oozes out, which we call latex. Very interesting. I have shown some figure there. Columbus in Haiti, 1496. He wanted to go to India, land somewhere else, and he found that the natives of that island were playing with something which he had never seen in Europe. They were bouncing some ball-like thing, which we call ball now, and he was surprised. Such a material they had never seen in Europe. And he also found that the natives used to waterproof their shoes, footwear, not looking like shoes, but they were wearing something which were waterproof, because the rains were heavy there. They wanted something to protect their feet. He also saw that the clothing that the natives were wearing was waterproof. They used to dip that in the latex and dry it in the sun, and it had that water repelling properties. He could not understand what this material is, but he was good enough, smart enough to take that and take it to Europe. Immediately the applications began. This is a material which is very useful. Sorry. One of the first applications was in America itself. People thought that it can be used as a carry bag for postmen. Postal department is a very important department in the United States with a lot of powers, almost like the United States president, because postal vans are never stopped if there is a delivery has to be given. And they started using the material which was taken by Columbus to make bags, postal bags, because to protect the mail. But the problem was, in summer, the bags became sticky. Articles could not be taken out. And in winter, it crumbled. Whole bag crumbled. Many of those roadside bags crumble now, even now, you can see that. So the material that was selected and taken with the interesting properties behave differently in different seasons, and they dropped the idea, a very difficult material, of using it. But then people started working how to improve the properties of that material. Cellulose, everybody knows, the structure is given. A scientist whose photograph is also given there. We'll talk about him slightly later. A film is shown. This is another interesting polymer which we have been using. Our ancestors used it. There are several other examples. Gutta percha, the wood pulp, resin. All these natural materials were used to make articles that were useful. But then, man is greedy. He wants more things, more materials. Almost tailor-made. We want to have a shirt which is made by a designer. So we want a material which should fulfill all our needs, the properties we want to inculcate in it. They started modifying the naturally occurring polymers. If this property is missing, why not make it? Why the rubber bag should become sticky and then become brittle? Why not improve the properties so that it behaves the way we want it to behave? And that's what exactly they tried. Modified natural polymers, a number of them. Substitute for shellac, as I told you, was made. Cellulose was modified to get you rayon, and in the work that was done by Charles Goodyear, early 1839, he took the natural rubber, put some sulfur, heated it low. The property is entirely different. The rubber as we know it, the tire that you see, it doesn't become sticky, nor it crumble. It has those properties which we wanted. And people say that Goodyear was lucky to get that combination. Nobody understands. He did a systematic work with the different materials, incorporating it in right proportions, ultimately coming up with the idea that sulfur is the material put in appropriate proportions along with heat, makes it a special material. In terms of chemistry, if you want to speak, it cross-links. Sulfur cross-links are produced between the giant molecules, making it rubbery. Applications immediately increased. That process is called vulcanization, by the way. Vulcan is the god of fire in Greek mythology. That's the name is derived from, vulcanization. Even today we do that. Wherever there is a tire, we say there is an iron, to indicate that Malayalis are into this business, because natural rubber plantations are mainly located in Kerala. This is what he did. Applications started mounting once that was done. Immediately, the beneficiary is the Queen Victoria. Her horse carriage had the steel rim. It is changed to rubber so that her ride on the horse carriage was smoother. you can see the shoes, the footwear they started making. Another name you have, Goodyear, you know, industry is there. Dunlop is another name which you come across. He had a problem, domestic problem for that matter. His son used to complain always, Papa, I will not ride a cycle because it pains. And his son used to come last in the class. Wherever cycle race used to be there, he used to come last. The problem was, during that time, cycle had only that rubber strip. There was no tire as we know the cycle today. John Dunlop was worried what to do. He wanted to make his son happy. While watering his plants in his garden, he happened to stamp upon the rubber hose, and he found that cushioning effect. Water was not passing at that time, it was hollow. Only air was there, but air within the rubber tube, it was folded. And he found that the cushioning effect is there. He immediately cut a piece of it, wound it round the rim of his son's cycle, and lo, the result. His son came first in the cycle race next time. Dunlop immediately patented that. The pneumatic tires, air-filled tires, where we pressurize the tires with air so that the cushioning effect is there. And it is due to John Dunlop. What we understand from this? The observation power of people. Every one of us make hundreds of observations every day. Hardly any of us make a scientific observation. He had something in mind, he stamped upon the tube, and he immediately could relate that here is the property which he can use to make his son happy.